Quantitative analysis of organic compounds. Next, estimation of nitrogen. Estimation of nitrogen. There are two chief methods for the estimation of nitrogen. First one is DUMAS method. Second one, Geldal method. These are the two important methods for the estimation of nitrogen. Let us discuss about the DUMAS method. In this method, first the nitrogenous compound is heated with copper oxide. Okay, it's first heated with copper oxide. In an atmosphere of carbon dioxide yields nitrogen. And the reaction is as follows. CX HyNZ. Okay. On reaction with copper oxide, 2x plus y by 2 CuO, it gets converted into carbon dioxide and water. Along with that, nitrogen is also produced. Okay. HCO2 plus y by 2 H2O plus Z by 2 N2 plus 2x plus y by 2 copper. Like this, the reaction is taking place. During this reaction, some oxides of nitrogen are also produced, which can be reduced to nitrogen by passing through copper gas. Okay. Now, let us explain the apparatus. Apparatus in the DUMAS method. It contains 3 units. Apparatus. First unit is carbon dioxide generator, in which carbon dioxide is produced and passed into the combustion tube. Okay. So, second unit is combustion tube. Combustion tube where combustion is taking place in a combustion furnace. Okay. The compound is heated in a combustion furnace, which contains different parts. Okay. First layer is a copper gauze to prevent the back diffusion of the products during combustion. Okay. First part is copper gauze. Copper gauze. Now, second part is next layer is the weighed amount of the organic compound, and copper oxide is taken. Excess copper oxide is taken in the next layer. Okay. Plus excess copper oxide is taken is the next layer. Okay. Now, the third layer is a layer of coarse copper oxide. Coarse copper oxide is taken, which is about 2/3 of the length of the tube. The length of the tube is copper gauze. Okay. Sorry, coarse copper oxide. Next part is reduced copper gauze. Okay. Reduced copper gauze. During this combustion, some oxides of nitrogen are also produced. So, in order to reduce that oxides and convert it into nitrogen, this reduced copper is used. So, here the reduction of the oxides is taking place and gets converted into nitrogen. Okay. These are the different parts of the combustion tube. Now, the third unit is Schiff's nitrometer. Third unit, Schiff's nitrometer, where the nitrogen gas is collected. Schiff's nitrometer. Schiff's nitrometer. So, the nitrogen produced after combustion will contain excess of carbon dioxide. So, we have to remove this carbon dioxide. For that, first we are passing through the Schiff's nitrometer. Okay. So, what will happen? The nitrometer contains potassium hydroxide solution in it. Okay. So at the bottom part of this Schiff's nitrometer, potassium hydroxide is present, and this potassium hydroxide absorbs the excess carbon dioxide present. Okay, and pure nitrogen is collected at the top of the graduated tube. Okay, nitrogen gas is collected. So from which we can obtain the volume of the nitrogen gas produced can be calculated from the graduated tube. Okay, so we will get the volume of the nitrogen gas. So from this we have to calculate the volume of nitrogen at STP. Okay, next we can explain the calculations. Calculations. First, mass of organic substance will be equal to, let the mass of organic substance equal W gram. Okay, let it be W gram. Now, the volume of the nitrogen collected will be volume of nitrogen collected in the graduated tube. It is a known volume. Let it be V1. Okay. Now the room temperature will be T1. Okay. T1 Kelvin. T1 Kelvin. And let the pressure at this pressure at room temperature will be equal to P1. Okay, this P1 will be equal to the difference between the barometric pressure and the aqueous tension at room temperature. Okay, so P1 will be equal to, let B be the, so let us take B be the barometric pressure. Okay, barometric pressure, and small b be the aqueous tension at room temperature. Okay, aqueous tension. So what will be P1? P1 will be equal to B minus B. Okay, from this we can calculate the volume of the nitrogen at STP. So volume of the nitrogen at STP be V. Let it be V. So we are calculating volume of nitrogen at STP. From this, after calculating this, we can calculate the volume, the weight of the nitrogen at STP. So first, volume of nitrogen at STP is equal to T1 into P1. P1 is, we know P1 is B minus B by V1. Okay, V1, the volume, known volume. Okay. Sorry. P1 V1 by T1. So V1 is the known volume, B minus B be the pressure at room temperature, and T1 the temperature at room temperature, into the temperature at STP is 273 by temperature, the pressure at STP is 760. So this will be the volume of nitrogen at STP. Now after calculating this, we can calculate the weight of the nitrogen at STP. We know that at STP, 22,400 ml of nitrogen weighs 28 gram. Okay. So the weight of nitrogen at STP will be equal to weight of nitrogen at STP will be equal to 28 by 22,400 into V1. Okay, sorry, V. We already, this is V. We already calculated this much value into, this will be the weight of the nitrogen at STP. Now we can calculate the percentage composition of nitrogen. Percentage composition of nitrogen will be equal to this value into 100 by 28 by 22,400 into V into 100 by the weight of the organic substance, known substance. We already, this W is a known volume, which is the organic compound we already taken. So, 100 into 100 by W. Okay. This will be the percentage composition of nitrogen. Like that we can calculate the STP. So all the volume, if we know all these values, we can easily calculate the percentage composition of nitrogen and STP. Okay.